Welcome to the Baseface Network.
Smoke on the terrace and into the kitchen. I don't want no other way of living. Smile so big, I wanna take a picture. Nothing can replace the feeling when I'm with ya. It don't matter what.
Hello everyone, my name is Muhammad Ibn Azhar and I'm from DTP2A. My matric card number is 10DTP20IF2002. Okay, today I want to talk about application of integration. Integration is the act of making different applications, each create for a distinct objective work together. Organization can achieve connections that modernize their infrastructure and enable agile business operations by combining and simplifying data and workflow between multiple programming languages. The gap between current on-premise system and rapidly expanding cloud-based enterprise app is filled in part via application integration. Application integration enable firms to coordinate a range of tasks across their entire infrastructure, allowing them to run more effectively and efficiently. This is done through smoothly networked processes and data exchange.
Based on the picture on the side, there is a graph that determines the x-axis and the y-axis, but the position of T is unknown. Where is its position on the x-axis and the y-axis? However, the position of the curve is given where x is equal to 8y minus 4y power of 2. Clearly the position is on the x-axis. There are two aspects which becomes two equations, among which the first equation is to determine the coordinate of T, and question number 2 is determine the volume of revolution when the shape aggregation is rotated completely about y-axis in terms of pi. So the solution for question 1 is use quadratic equation, and solution for question 2 is calculating the volume of solid by using definite integral.
As you can see on your screen right now, the solution for this question is use the quadratic equation. Use your calculator, then press the mode section and select equivalent, and then select the degree section. Enter the value -4x to the power of 2 as A, the value 8 as B, and finally the value 0 as C. After the process is finished, you will get y equal to 0 and y equal to 2. So coordinate 7 is 0, 2 of x-axis is equal to 0 and the y-axis is equal to. That's all. Thank you.
Hello, my name is Muhammad Shamil Zarfan bin Sulpian, number metric 10DP 21F2010, and I'm from program DTP2A. And I will explain about how to answer question 2. First of all, we have seen how to compute certain areas by using integration. Some volumes may also be computed by evaluating an integral. Generally, the volume that we can compute this way have cross sections that are easy to describe. So, how to determine the volume of revolution when the shaded region is rotated completely about y-axis in terms of pi? First of all, the formula that we need to use is how to find the volume. V equals to integral BA by x cube dx. To find the x, we replace x with 8y minus 4y squared, and then we write it integral 20 by in bracket 8y minus 4y squared in bracket close bracket dx. Because 8y minus 4y squared have 2 power, so we write it 2 times, and then multiply each other in the first bracket and the second bracket. So we will get 64y squared minus 32y cubed minus 32y cubed plus 16y squared. I'm sorry about the mistake in the figure, so I will say the correction. After that, we get the answer by integral to 0 in bracket 16y whole 4 minus 64 cubed plus 64 square in bracket dx. So then we use a method of integral that the power at the upside that you see at the figure. I'm plus 4 plus 1 minus 4 plus 1, and also I will do the same method to the other number, that 3 plus 1 and minus 3 plus 1 also. And for the 64 square also, I plus the power 2 plus 1 and divide 2 plus 1. After that, I get the answer that the next square is 5 and also 4 and also 3. And then we apply the y with the same equation, that is y equals to 2. So then we write it back, that y in bracket 16 in bracket 2 power 5 minus 5, and also minus 64 in bracket 2 power 4 over 4, and plus 64 in bracket 2 power 3 over 3 and minus 0. How I get the 0? That if we use the same answer, even we use a calculator, we still get 0. So I make it simple, that I replace it with 0. And then the next answer, we get the pi in bracket 102.4 minus 256 plus 170.67 in bracket. After that, we use a calculator and write the number in the bracket, and then we get the real answer, 17.07 per unit cube. That is the volume of the revolution when the shaded region is rotated completely about y-axis in terms of pi. So that's all about my explanation.
In this session, we review the second core calculus problem, which is locating the coordinate of t when the shade region is fully rotated about the y-axis in terms of we can calculate the volume of revolution using the definite integral that we got using limits. We clearly learn about application integration for computing object volume in this chapter final lesson.